Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of integration. Integration is basically the opposite of the derivative. So if I take a f of x and I take the derivative of it, okay, whatever that f of x is, then I end up with an f prime. Well, I would take the integral to end up right back where I started with the f of x. Technically that should be a big F. To be the same as this big F, okay? So they're opposite, so we should say derivative, the integral, and they take you back and forth between these two. Okay? So what are some of the uses? Well, we can use integration to sum up areas between two curves. You can find volumes, anything that's accumulating. Let's say you know a revenue equation. You could integrate the revenue equation to figure out the revenue based on some quantity sold, X, whatever the situation may be. Okay, so right now, just looking at the basic concept here, what we're going to be doing, if you remember, they're opposites for derivatives, and in the derivative, what did we do? We took the thing down and we multiplied and then subtracted 1, right? Well, here we're going to do the opposite because it's the opposite direction. So what we're going to do is first pull out the constant, and then we're going to add 1 and divide by the same thing to get this. Okay? This only works if this x to the n is in the numerator and it can't be multiplied to something else. It just has to be an x to some power of n. Okay? So if it's on the bottom, remember your algebra rules, you can bring it up by making it negative. Also, there are times that you'll see fractionals. Don't forget your algebraic rule of that. Okay? So that's basically it. Now you notice that there's a plus c here. What is a plus c? Well, what is the derivative of x squared plus 5? Well, that derivative is 2x. And the derivative of the 5 is 0. Any constant that we have there, the derivative will always be 0. Okay? So when you integrate, to go back to the original function, let's just do the first really basic example. If I did that integral, I would get a 2, there's nothing there, so it's implied to be a 1. So 1 plus 1. Okay, so we do get the x squared that we had originally, but we don't get the plus 5. Okay, so we know that there might have been some constant, so the way we write this answer is we say x squared plus some constant. And you could be given some initial conditions. You could be told that when y is equal to 1, x is equal to square root of 3, and you would have to plug in here your y and x to figure out what your c is. So you would get and then you can figure out what this particular c is. It would be -2, and then you would plug in. Okay, so this would be referred to as what's called a general solution. But once you figure out what c is with these initial conditions, that's a particular solution. So your particular solution in this case would be x squared minus 2. You might say to yourself, well, that's not a plus 5. Yeah, I just happened to pick an x and y value that gave me those conditions. If I wanted a plus 5, I could have said x was equal to 1 and y was equal to 6. Okay, and then that would give me that equation there. All right. So don't be afraid to use algebra. If you see stuff, multiply it out, FOIL it out first. If you see stuff that's, looking funky, well, you can always separate that denominator into two different fractions. Okay, you can do long division, don't forget that. But that's basically it for the power rule. This is the most basic way of integrating something. There are much more complicated techniques, so just go ahead and get this out of the way. Feel familiar with what we're doing when we're integrating. Okay, I hope I've cleared up the fundamentals for you. Make sure you check out the example videos. As always, practice, practice, practice. Thank you and have a nice day.